Okay, question 1 we have, for t in the interval 0 to 31, the rate of change of the number of mosquitoes on a tropical island at time t days is modeled by the function r of t is equal to 5 square root t multiplied by cosine of t over 5 per day. There are 1,000 mosquitoes at t equals 0. So the first question says, show that the number of mosquitoes is increasing at t equals 6. Since this equation, r of t, is the rate of change of the number of mosquitoes, this is the only function we have to use. We don't have to integrate it or differentiate it yet. So all we have to do is, since they gave us t equals 6, we just have to find r of 6. So plug in 6 into the function. So 5 square root 6 multiplied by cosine of 6 over 5. And if you plug this into a calculator, you're going to get 4.44, like estimated to be 4.44. And since this number is greater than 0, and the function we just calculated was the rate of change function, which can tell us if the function is increasing or decreasing. If the function is greater than 0, then it's going to increase. If it's less than 0, then it's going to decrease. But since 4.4 is a positive number, we can say that the number of mosquitoes increases as r of 6 is greater than 0. And this is our final answer. Question 2, or 1b, we have at t equals 6, is the number of mosquitoes increasing at an increasing rate or increasing at a decreasing rate? So we have the number, we found that at t equals 6 it's increasing, but we don't know if it's at an increasing rate or decreasing rate. To do that, we need to find the acceleration. And to do that, we need to find the derivative of basically this function, which is the rate of change of the number of mosquitoes. So r prime of t, we're going to find using the product rule. So u is equal to 5 square root t. V is equal to cosine of t over 5. Du is equal to 5 divided by 2 square root t. And dv is equal to negative 1 over 5 sine of t over 5. And product rule is vdu plus udv. So vdu is 5 over 2 square root t multiplied by cosine of t over 5. And then plus udv, so basically minus square root t, because 5 divided by 5 is just 1, sine of t over 5. And this is r prime of t. So this is the acceleration function basically. And now all we have to do is plug in 6. So if you plug in r prime of 6 into a calculator, this is going to be negative 1.91. And this is less than 0. So since it's less than 0, this is going to be increasing at a decreasing rate. So we found that just r of 6 is positive, but r prime of 6 is negative. So the answer is increasing at a decreasing rate. One C, we have how many mosquitoes will there be at t equals 31 to the whole number. So now, before we had to find the rate of change of the rate of change, but now we have to find how many mosquitoes there actually are, not the rate of change of it. And to do that, we're going to have to integrate the function now. Whenever we find the integral of a function that gives us the rate of change, we're going to get the unit itself. So in this case, the unit is mosquitoes. So r of t we know is 5 square root t cosine of t over 5. And since they say at t equals 31, first we're going to find the integral of the function, so from 0 to 31 of r of t dt, and if you plug this into your calculator, you're going to get negative 35.6. And this is not the final answer, because in the question, they said at t equals 0, there are 1,000 mosquitoes. So we have to add 1,000 to this number, because that's how many there were originally. So 1,000 minus 35.6 is going to be estimated to be around 964 mosquitoes. And this is our final answer. 1D, we have, what is the maximum number of mosquitoes in the time interval 0 to 31? So when they say the maximum number of mosquitoes, that's when we have something around, like in our graph of the integral function, we have something like this, where we have a maximum point. And at this maximum point, the slope is 0. And we are given the slope function, which is r of t. So all we have to do is set the r of t function equal to 0. So r of t equals 0. And if you plug this into your calculator, you should get the values t equals 0, 5 pi over 2, and 15 pi over 2. So this means that at these values, this function is going to equal 0, which means that there is a maximum or minimum point, wherever the slope is 0. So now, we're given these values, and we have to see how many mosquitoes there are in each of these time intervals. So the first one, let's just do over here. Remember, we're adding 1,000 because that's how many was there at t equals 0. 1,000 plus from 0 to 0 r of t dt. And if you remember, if the bounds are the same, then this is just going to be 0. So this is just 1,000. And then let's do it over here. 5 pi over 2. 1,000 plus from 0 to 5 pi divided by 2 r of t dt is equal to, if you plug this into your calculator, you're going to get 1039. And then 15 pi over 2, 1,000 plus the integral from 0 to 15 pi over 2 r of t dt is equal to 842.4. So from these three values, we can see that 1039 is the highest. And this is when t is equal to 5 pi over 2. So we can say the maximum number of mosquitoes is 1039 at t equals 5 pi over 2. And this is our final answer. Okay, question 2 says, for the time interval 0 through 6, a particle is moving along the x-axis. The particle's velocity is the function v of t is equal to 2 sine of e to the t over 4 plus 1. The acceleration is a of t is equal to 1 over 2 e to the t over 4 of cosine times e to the t over 4, and x of 0 is equal to 2. And x of t is the position function, but they haven't given that to us. We're only given the velocity and the acceleration. So part A says, is the speed of the particle increasing or decreasing at t equals 5.5? So first, let's find the velocity at t equals 5.5. So to do that, all we have to do is just plug in 5.5 into the velocity function. And this is going to be 2 sine of e to the 5.5 divided by 4 plus 1, and this is going to equal negative 0.453. If you put it into your calculator, this is what you're going to get. So the velocity is negative, but that's not our answer. The question's asking, is the speed increasing or decreasing, and that's different from the velocity. The velocity here is just decreasing, which means that the values are just going down. But speed means that it should be either the velocity and the acceleration should be negative or positive. So we have to find the acceleration now. So all we have to do is find a of 5.5, which is equal to 1 over 2 e to the 5.5 over 4 multiplied by cosine of e to the 5.5 over 4. And if you plug this into your calculator, this can be negative 1.36. So both of the functions are negative. So v of t is less than 0, and a of, or not t, 5.5, and a of 5.5 is also less than 0. Since the signs at the same point are the same, we can say that the speed is increasing. So if in a case where the velocity and acceleration are different signs, that means the function is the speed is decreasing. And what that looks like, if we just have like a graph here, if the speed is increasing, the graph is going to be moving away from the x-axis, and if the speed is decreasing, then we're going to be moving closer to the x-axis. And then if we cross it, and we're going to be moving away from the x-axis, here the speed is increasing, here the speed is decreasing. So you can just think about it by this rule. If the signs are the same, then the speed is increasing. If the signs are different, then the speed is decreasing. Or you can think about it graphically, if the function is moving away from the x-axis or moving closer to it. 2b, we have find the average velocity of the particle for 0 through 6 in the time interval 0 through 6. So the formula for average velocity is displacement divided by time. So we're given time, which is 6 time units, whatever the time units is. And now we need to find the displacement. And to do that, we need to integrate the velocity function, because that's what's going to give us our displacement. And the bounds are going to be from 0 through 6, because that's what the time interval is. So from 0 through 6, v of t dt is going to equal, if you plug this into your calculator, you're going to get 11.69 units of displacement. And remember, this is just a displacement, not our average velocity. But to get that, we need to divide by our time. So 11.69 divided by 6 is equal to 1.95. I guess you could just say displacement over time. And this is our final units, or final answer. 2c, we have find the total distance traveled from t equals 0 to t equals 6. In part B, we found the total displacement. So the only difference between displacement and distance is the absolute value of v of t. So we're going to do the exact same thing. So from the bounds 0 through 6, but instead of just v of t, we're going to do the absolute value of this and then find the integral of that. So if you put this into your function, you're just going to get 12.57, I guess, distance. And that's the final answer. 2d, we have, for the time interval 0 through 6, the particle changes direction exactly once. Find the position of the particle at that time. So, to find the time when the particle changes direction, we need to see where the velocity function crosses the x-axis. So that means we have to find where v of t is equal to 0. But not just when it's equal to 0, when it crosses it. And what that basically means is, like, this is the x-axis, this touches the x-axis, but it doesn't cross it, it bounces back up. To cross it, you would literally just cross it. So, if you plug in, or if you set v of t equal to 0, the only t value you're going to get is t is equal to 5.2. And to check that this actually crosses the x-axis, you can make a sign diagram. So from 0 through 6, starting from 0, and let's just say this is 5.2. This is positive and this is negative. So on the left side of 5.2, it's above the x-axis, and to the right, it's below. So that means it crosses the x-axis. So we can confirm that this is when the particle changes direction. But now the question asks, find the position of the particle at that time. So to do that, all we have to do is, once again, integrate the velocity function from 0 through 5.2. So v of t dt is equal to 12.1. And this is not our final answer, because if you remember in the question, they gave that x of 0 is equal to 2, which means that the particle was already started at 2. So we have to add 2 to this. So 12.1 plus 2 is equal to 14.1. And this is our final answer.